So we have learned about the motion with a constant velocity. But velocity not always constant. For example, one example is this, what is the speed of this ball now?
Zero.
Zero. When I, for example, throw it, the velocity will be not zero.
100.
So velocity change, it was zero, become velocity, and then keep calling it again zero. So it changed now. When I drop it, its speed is zero now. And because gravity pull it down, it will move in and it will be falling with increasing velocity. So velocity can change. How we can describe change in the velocity? We need to introduce another physics quantity called acceleration. And that's our focus today. Acceleration. And acceleration is denoted with letter A. And acceleration is a rate of the change of velocity. So let's use U for initial velocity. Initial means at time equals 0. Initial velocity. V final velocity. So acceleration will be equal rate of the change of velocity. So final minus initial will give us how much velocity change, and divided by time will give us rate of the change of the velocity. So what will be the unit of the measurement for acceleration? Velocity measured in meters per second, and we divide by second. Will becomes meters per second squared. It's meters per second, and that is meters per second squared.
So is that what?
That is the unit for measurement of the acceleration. So let's say car was moving with velocity equal 20 meters per second, and then driver sees that some obstacle ahead and press the brake and slows down to 5 meters per second over the interval of the time of 0.5 seconds. What is the acceleration? We find a change in the velocity final minus initial, 5 minus 20 divided by 0.5 will be equal negative 15 divided by 0.5, negative 30 meters per second squared. What negative tells us?
It's going down. It's slowing down.
It's slowing down. Will the minus always tell us that it's slowing down? That means the acceleration, if you take velocity was in the positive direction, is acceleration in the negative. So in this case, it's slowing down.
But if you're going backwards,
If car will be moving in the negative direction, and acceleration will be negative, what will be happening?
it's staying on.
It will be speeding up, but in the negative
So
direction.
how can you differentiate between if it's going in a negative direction or if it's just slowing down?
If it's going
We,
backwards or backwards.
then we first, is speed increasing or decreasing? Speed is decreasing, it's slowing down. And we always choose some direction as positive. Because velocity has direction, same acceleration, we need to choose direction. So makes sense how to calculate acceleration. Let's rearrange this formula, make V as a subject. Can you tell me what V will be? Rearrange this formula, make V as
plus
a
U.
will be U plus A t, if you rearrange the formula. Will be initial velocity plus acceleration times time. So let's say other situation around, car was moving with the initial velocity of, let's say, 7 meters per second, and then started accelerating, and over the time equal 5 seconds. What will be its velocity if it will be accelerating for 5 seconds with acceleration 2 meters per second squared? What will be its velocity? Substituting numbers, we'll get 7 plus 5 times 2 will be equal 17 meters per second. Make sense? V final velocity equal initial times acceleration plus acceleration times time. Make sense?
Yeah.
And now we will look into how the distance and displacement will be changing when car or any object moving with acceleration. To do this, let's recall what we have found, learning about the motion with uniform acceleration. What we have found, what does area if we had velocity times graph, and it was motion with a constant velocity. What area under the velocity time graph, what it was telling us? Displacement. It was telling us displacement. And that always will be the case. Area under the velocity time graph gives us displacement. So let's sketch this graph. Let's sketch how velocity will be changing over the time when motion with acceleration. That will be straight line but not horizontal. That will be a line like this. So that will be initial velocity. It's moving on to a certain period of time. What will be acceleration for this graph?
Gradient.
It will be gradient. When you have velocity against time, and there is acceleration, acceleration will be gradient of this graph. Make sense?
Yeah.
Now, let's find area under this graph to find the displacement. What shape is this?
Quadrilateral. Trapezium.
Trapezium. It is trapezium. It is trapezium on the side.
Oh, wow.
If you look, if you turn it around, it will look like this. You see, it's trapezium, just turn on the side. What the formula for area of the trapezium?
1/2 A plus B times height.
Yes. So what will be our basis? U.
What is that?
This is final velocity V, and this is time. So we will have the area which will be equal as displacement will be equal U plus V over U plus V over 2 times time. Base A plus B, basis A, B, divided by 2, and height is a time. So that is the formula how we can find the displacement. Because displacement will be area under the graph. And that will be formula for area under the graph.
So that's under the graph.
If we will be changing direction, then what is above x-axis, we will first we can use this formula only for straight line.
So what is
If
x
we will
stand
be changing, we need to break it into the parts and calculate area of each part. If it will be moving backwards, yes, it will be moving backwards, then it will be below time axis, and we will need to take care with the minus. We'll come to that. So that's second formula. So we had formula number 1. We have formula number 1 describing motion with the uniform acceleration. We got formula number 2. Now in this formula, let's substitute V from the equation 1. Let's substitute V from the equation 1. Number. Equation. We will have S equals U plus AT over 2 times T. Instead of V, we substitute the expression. We substitute U plus T instead of V. Instead of V equal U plus AT. And we substituted it.
Yes, sir.
Now let's collect like terms and simplify, and we will get S equal UT plus AT squared on 2. That's formula number 3. That is formula number 3.
You just expand.
That is formula number 3 that describes motion with the acceleration. And we will derive the 4th formula. Now, effectively, we need just 2 formulas, this and this. We can find anything using just those 2. But practically it's much more convenient to use 4 formulas. And we already derived the 3rd, we will get the 4th. To get 4th, let's...
Do we need the accelerator? No, nothing.
Let's square this. Let's square this. Square equation will square both sides. So left hand side will have b squared equal, we square this side, we will have u squared. You do remember a plus b squared equals a squared plus 2ab plus b squared. From year 8, you should remember that. Yeah, it starts from year 8, 9, 10, so you should know it. B squared equals u squared plus 2ab will be 2 times u times at plus 2uat and plus a squared t squared. I just squared right hand side.
Yeah.
Why does that help?
Okay.
How does that help?
Yeah, that makes it worse.
Yeah. When you have b squared.
Let's see.
Oh, let him cook.
We will simplify it now. Now, let's take here, let's take 2a as a common factor here. So we have b squared equals u squared plus 2a. What will left from this when you take 2a as a common? ut.
And what's
What will left from here?
t squared.
8 squared on 2.
Sure.
And what is this? That is what we just derived, is displacement.
Oh my god.
So this formula becomes
What was it really on that? Like,
b squared equal u squared plus 2as. So that's formula number 4. You don't have to be able to derive those formulas, but you need to, even you don't have to memorize them, they will be on the formula sheet always, those formulas. But we will learn how to use them to solve any problem, or almost any problem with the motion with acceleration. Yes, you're right.
What is v squared for? Like, you know that's
V, velocity squared.
So why do we need a square?
Why? Because
to get to that.
Oh.
we
It would just be v equals
It's
root.
just-
Why do we need
We don't need
Why do we need this?
to do it now.
Does he make? Well, he's just giving us all the
So-
equations we need.
Does it make sense how I derive these 4 equations?
Yeah.
Yes.
Now let's write them all together and have a careful look. And that will tell us a lot.
Mr. Way, did you make up these equations?
I'm afraid they were made few hundred years before I was born.
Oh.
So, equation number 1, we have B equals U plus AT. Second, we have equation number 1. Equation number 2, we have S equal U plus V over 2 times T. Then we have S equals UT plus AT squared on 2. And we have V squared equal U squared plus 2AS. Number 2, 3, 4. There are, if you consider, 5 variables describing motion with uniform acceleration. U, V, A, T, and S. How many of them are present in each equation? How many of these? I will rewrite them in a little bit different way.
4.
Yes. V, 18. That's why those formulas often called Suvat equations. They call Suvat equations. These 4 formulas of 1. Now there are 4 variables in each formula. And you always will have 3 known quantities and need to find 4th. So all you need to do, just look through those equations, which of them connect 3 known and 1 unknown.
Sure.
And you will be able to find it. For example, if you know, let's say, question. Leo was walking initially with velocity, initial velocity 1 meter per second. Then he accelerates with a rate of 0.5 meters per second, and it accelerated for 2 seconds. And question is, what distance he will cover in these 2 seconds? So we're looking for S. Which formula connects U, A, T, and S?
3.
Number 3. So we substitute numbers the S equal 1 times 2 plus
Like, what is S then?
distance or displacement. In this case, it will be distance because no change in the direction. 0.5 times times 4 divided by 2 will be equal.
2 plus 3.
Will be equal.
3.
3 plus
Will be
4.
will be 3. 0.5 times 4, 2 divided by 2, 1, so 3 meters. So in 2 seconds he will cover 3 meters.
That's so fast.
Yeah, that's incredible.
5 meters squared.
Square, yes. Yes, thank you.
Good one.
Yes,
So is the accelerate equals the first acceleration? Because what if there's like multiple steps?
what do you mean multiple steps?
Because this right now we're doing like initial and then 1 acceleration.
let's see.
Sorry?
We're doing initial and then 1 acceleration. Do we ever do more than 1 acceleration?
What do you mean more than 1 acceleration?
Like a jog and a run.
So when then acceleration change over the time, yeah, it could be the case. But we will need to consider each part of the motion separately.
Okay.
There will be no multiple acceleration at the same time.
Yeah.
Now, another example. If we have, I'm walking with the velocity of 3 meters per second, then he accelerated acceleration 2 meters per second squared, and he get to the velocity of 8. So final velocity is 8 meters per second. Question is what distance he will cover during his acceleration. Which formula we should use?
Uno.
Number one.
U, A, D, and S. Is number 1 with S?
Oh. We don't use one with.
Number 4. That's why we need to use number 4 when we have three of those. So we have 8 squared equals 3 squared plus 2 times 2s. So 64 equals 9 plus 4s. 4s equals 55. So s equal, what s equal? If equal 55,
Somewhere around.
13.75.
Oh my god, this is mathematician.
Wait, how do you get 45 equals 55?
No.
It is 4s.
35.
4s equals 55. Sorry, I apologize for my handwriting.
You're good.
Yeah, check if this is correct.
It is.
Ralph, you're so slow.
Yes, Lord.
Alright,
Please.
you're so slow.
Why is it?
You
why
can't
is it-
see.
why is
Can
it-
I please hear the question? Yes.
Why is it number 4? And not number
Because we have U, A, D, and S.
You don't have time.
We don't have time. So none of those is suitable.
Well, if, for example, the question often, if you add the S and J,
Then,
Are you still like saying?
for S we find this. If you know U, A, D, and looking for T, which equation we need to use? One. If you know U, A, and B, and looking for T, 1.
we
So,
could use 2 as well. Isn't that
but it's always better to use what's given to you.
okay?
Now, so that is how we solving most of the problems with the motion with the constant acceleration. We list what we know and what we're looking for. And we look which of them connect 3 known, and it's always will be 3 known, with that one
That's good.
unknown. So that's why for we need those 4, because they cover pretty much all possible situations. And that's all for today.
Like and subscribe the whole time.
Like and subscribe, Ukraine.